Hello students, in this question ABCD is a trapezium in which AB is parallel to DC. AB is parallel to DC. These two sides are parallel. Now it says BD is diagonal and E is the midpoint of AD. E is the midpoint of AD. A line is drawn through E parallel to AB. This line has been drawn here through point E, which is parallel to AB. Okay, and intersecting BC at point F. Well, we need to prove F is the midpoint of the side BC. So let's continue. Since AB is parallel to DC, it's given. AB is also parallel to EF. This is also given. What does that mean? That means DC and EF also should be parallel. DC must be parallel to EF also. Well, now in triangle ABD, we have to apply the converse of midpoint theorem. What is converse of midpoint theorem? It says that if you have a triangle and you choose a side, take the midpoint of it and join a line parallel to the second side. Suppose this is your first side here, you have chosen, and the second side is the bottom one. You draw a parallel line to the second one through that midpoint this way. This one is parallel to the second side. Then what is the third side? Here. According to converse of midpoint theorem, if you do so, the point of intersection here is the midpoint of the third side. Means the line drawn parallel to the second side will bisect the third side. Okay. So in triangle ABD, E is the midpoint. E is the midpoint of AD, and EF is parallel to AB. So the point of intersection on the third side, let us name it to be G. So G is the midpoint of BD. Reason is converse of midpoint theorem. Converse of midpoint theorem. Okay, so G is here the midpoint. Now let's work in the second triangle. The second triangle is now in triangle BCD. In this triangle, here G is the midpoint. G is the midpoint of BD, and GF is parallel to DC. In the starting of our proof, we proved that DC was parallel to EF. DC was parallel to EF. So we can write that GF is parallel to DC. Okay. So here GF is parallel to DC. That means F must be the midpoint, is the midpoint point of BC. Reason, again, converse of midpoint theorem. So in this whole proof, we have used the converse of midpoint theorem twice. Finally, we have proved it. This is what we needed to prove. F is the midpoint of BC. We did it here. So it's done.